All right, here we go. Welcome to the review for three-dimensional geometry. We're going to start with number 1. It says, given the following solids, A, we're going to name each solid below, and then we're going to identify which figure can have the same cross-section as a cone. So think of like an ice cream cone. So just also remember that prisms are named by their bases, which are congruent and parallel. So pause the video, see if you can name them, and I'll be right back. All right, so did you get the first one? The bases that are congruent and parallel are these rectangles. So this is a rectangular prism. The bases here that are congruent and parallel are the triangles. So this is a triangular prism. Remember, prisms aren't always sitting on their bases. So you have to look for the figures that are congruent and parallel. These are hexagons, 6 sides. So this is a hexagonal prism. And the last one is a sphere. So if we were to cut these like a cake, just think that they're in the shape of a cake, which is the only one that would have the cross-section of a cone, and that's going to be your sphere. Okay. Here, number 2, it says to state and sketch the figures formed if the triangle and rectangle regions are rotated around the provided axis. So if we were to rotate this around the axis, all right, this one and this one will both look like cones. Okay? And on the bottom here, if we were to rotate these, all right, if we were to extend this out and rotate it around in a circle, these are going to end up looking like soup cans. All right, so if we do this, remember if you take off the label to a can, the label is actually a rectangle, but when you spin it, it turns into a circular, it has a circular base, which makes these cylinders. All right, and I'm going to meet you on the next question. Number 3, I started out by drawing some pictures. So it says Jaden is comparing 2 cones. Here's cone A, cone B. The radius of cone A is twice as long as the radius as cone B, and the height is twice the height of cone A. So the volume of cone A, they want you to see, is it twice, 4 times equal to the volume, or equal to half the volume? So what if we said the radius of cone A has a radius of 10, which would make the radius of cone B 5? And if we said that the height of cone A is 2, then the height of cone B would be 4. Okay, so that's the radius of base A is twice the radius as base B, so 10 and 5. And the height of cone B is twice the height of cone A. So I went to my reference sheet from New York State, and I found the volume of a cone formula. And now I want you to pause the video, plug these numbers in, and let's compare the volumes. So the volume of the cone is 1/3 pi times the radius squared times the height. So if the radius is 10, 10 squared is 100 times 2, 200 divided by 3 pi. The volume of cone B would be 5 times 5, 25, times 4 would be 100, right, 4 quarters, divided by 3. So what do we know? The volume of cone A is 200 over 3, and the volume of cone B is 100 over 3. Times pi, of course. So the volume of cone A is going to be twice the volume of cone B. Now, if you want, you can pause the video. You could try any different numbers. Just make sure that the radius of A is twice the radius of B, and the height of cone A is half the height of cone B, and this will work out every time. You'll get different numbers, but the volume of cone A will always be twice the volume of cone B. Okay, number 4 is a water balloon in the shape of a sphere. So I drew a sphere. The maximum diameter is 400 centimeters, which means the distance from one side of the circle to the other is 400. We're going to have to find the radius. So 400 centimeters divided by 2, that gives us 200 centimeters. That's going to be the radius. It's filled. It says, what is the volume to the nearest cubic meter? Now here's the other issue. They gave us the unit of centimeters, but we need meters. So if you remember, 1 meter is 100 centimeters. So to find the radius in our final answer of meters, we're going to take 200, divide by 100, and that's going to give you 2 meters. So the radius is 2 meters. And then if you go to your formula page, the volume of a sphere is 4/3 pi r cubed. All right, so write down that formula, fill it in, and then come back. So the volume is 4/3 pi times the radius of 2, and we're going to raise that to the third power, okay? And it does say to the nearest cubic meter, so you're going to type all of that into your calculator, and you're going to get 33.5, and round it to the nearest cubic meter. We're going to round to the nearest whole number, so the next number is 5 or more, so we're going to round up to 34. You can leave your answer like that, or you could write meters cubed, so either one is fine. And I'll meet you on the next question. Find the volume of the right rectangular pyramid. So we're going to go to our pyramids formula, and we see that the volume of a pyramid is 1/3 capital B times H. So it's 1/3 capital B. Remember, capital B is the area of the base formula. Well, remember, prisms, pyramids are all named by their bases. So this is a rectangular pyramid. So the capital B is really length times width, base times height, however you want to do that. It's the base and height, the length and width of the two-dimensional figure. And then this H represents the height of the actual pyramid. Okay, so volume is 1/3 times the length times the width of 12 times the height of 16. And when you plug that into your calculator, you get 1,920, and it would be units cubed. Okay, number 6. What is the volume of a cube in cubic centimeters? So we want it in centimeters with an edge length of 6 meters. So once again, remember that 1 meter is equal to 100 centimeters. So the first thing we're going to do is take 6 times 100, which is going to give us 600 meters, and that's going to be the length of one of our edges. So this is a cube, so you might want to draw yourself a cube. Okay. And we know that the length is 600 centimeters, excuse me. The width is 600 centimeters, and also the height is 600 centimeters. So if you look at the volume of any prism, it's capital B times H. And remember here that capital B is the area of the base formula. Since this is a cube, it is a square base. So if you want to use length times width, maybe you want to use side squared. Volume is going to be 600 times 600 times 600. So it's the area of that square base times the height, the distance between the two congruent parallel bases. All right, so this is 216, 000, 000 centimeters cubed. Okay, but again, you can leave off the unit of measure if you want. And we're going to go to the next question. Number 7, a packing carton in the shape of a triangular prism. So remember, prisms are named by their bases. So the base is going to be a triangle shown in the diagram below. What is the volume in cubic feet? Well, when you look at your formula sheet, you're going to find out that the volume of any prism is capital B times H. The area of the base formula in this case is a triangle, so 1/2 base times height. So it's going to be the volume of this the area of the two-dimensional figure times the height, which is going to be the distance between those two triangles. Okay, so the first thing that we needed to show here was this is all in inches, but they want our final answer in cubic feet. So we remember that there is 12 inches in 1 foot, so 3 divided by 12, we're going to get 0.25 feet. 6 divided by 12 is 0.5 feet, and 24 divided by 12 is 2 feet. So when we plug into our formula, it's 1/2 remember the perpendicular distances, so the 6 times, the 0.5 times the 0.25, right, the perpendicular base and height of the two-dimensional figure, times the 2 feet, which is the distance between the two triangular bases. All right, and when you plug that into your calculator, you're going to get 0.125. You can leave your answer there. If you want to do units of measures, it's feet cubed. So number 8 says find the volume rounded to the nearest tenth, so you know you're going to get a decimal, of the right circular cone. So we're starting out with the formula of 1/3 pi r squared h. So volume is 1/3 times pi times the radius, which is the 14, right? They told you the radius is 14. We're going to square that, and then what they're giving you is the slant height. What we actually need is the height of the cone, which is that perpendicular distance from the center of the circle to the top of the cone. So the first thing we're going to have to do in order to find that height is we're actually going to need to do the Pythagorean theorem. Okay, because we have a right triangle here, and we know that this is A, This is our B, and the side across from the right angle is always our C. So we're going to start out with a squared plus 14 squared is equal to the square root of 1037 squared. And when you put this into your calculator, 14 times 14, and that is 196. And when you put in the square root of 137 squared, you get 1037. You're going to subtract 196 from both sides, which is 841. Then we're going to take the opposite of squaring, which is the square root of both sides, and we get a to be 29. And now you can fill that into your formula, and I will meet you at the answer. Okay, when you type that all into your calculator, you should get 5,952.27. We're rounding to the nearest tenth, so since the next number is 5 or more, we round up to 3. The next question, what is the volume in terms of pi, so that means do not put pi in your calculator, of the cylinder represented in the diagram below? All right, the 12 represented the diameter. Did you remember to divide by 2? So when you plug into your formula, pi r squared h, it's pi times the radius of 6 squared times the height of 27. You get 972 pi centimeters cubed. Again, you can leave the units of measures off if you want, but if you put it in, just make sure you do it correctly. All right, an oblique circular cylinder has a height. Remember, height is always the perpendicular distance. The height is going to be 8 meters, and the volume is 392 pi. Okay, find the radius of the circular base. So once again, go to your formula sheet. The volume equals pi r squared h. The volume is 392 pi equals pi times the radius squared times 8. We're going to divide by 8 pi. Boop, boop. The pi's cancel. You end up with 49 equals radius squared, and the opposite of squaring is square rooting. So the radius comes out to be 7. Okay, the next question talks about the Great Pyramid of Giza. It is a regular pyramid, so the volume of a pyramid is 1/3 times capital B, which is the area of the base times the height. The area of the base is a square base, so I actually, instead of using length times width, I'm going to use side squared. It has a volume of 2,592,276 square meters, and the height is 146.5. So I'm going to, in my calculator, first divide by 146.5. Hit enter, then I'm going to divide by 1/3. Okay, so you should have gotten 5,300 or 53084, 53,084.15017 is equal to the side squared. The opposite of squaring is square rooting. You get 230.3, but they wanted it to the nearest meter, so you're going to round to the 0. So 230 meters is equal to one side. You have a square base. Okay, so you have a square base pyramid that has a volume of 96 inches cubed, and they gave you the height to be in feet. So we need to switch over everything into inches. So remember, there's 1 foot is equal to 12 inches. So therefore, the height is going to be 12 inches. All right, so plug that on in, and I'll meet you right back here. All right, in some way, shape, or form, you should get 96 equals 1/3 times the side squared times 12. If you want to do a 1/3 times 12, that gives you 4. Divide by 4 on each side. 96 divided by 4 is 24 equals side squared. The opposite of squaring is square rooting. And it says to leave your answer in simplest radical form. So two numbers that multiply to be 24 are 4 times 6. The square root of 4 is a perfect square. That's 2. 6 has no perfect square factors. So your final answer is 2 radical 6. All right, so we've got a rectangular tabletop made of maple wood that weighs 43 pounds per cubic foot. So for every 1 foot, it's going to be 43 pounds. The length is 8 feet. The width is 3 feet. And the thickness, the height, is 1 inch. We had to change that into feet. So it's 1 foot is 12 inches. So this becomes 1/12 feet is going to be your height. So when you plug this in, the volume is the length of 8, the width of 3, the height of 1/12, the volume is 2. And to find the weight, it's going to be for every 1 cubic foot, you're going to be 43 pounds. So therefore your answer is 2 times 43, 86 pounds. All right, there was a lot going on here. You definitely want to go back and relook at this, but you're doing a great job. Keep practicing, keep looking at that formula sheet, and you have got this. Have a great day.